Is my voice coming?
Yes, Ashok.
Thank you, sir. Thank you. So Vinay, are you
You
controlling
controlling
this
this
PPT?
PPT?
Yes, sir. So
So,
right now you are controlling.
so you
So
just
you
take
just take
control and keep
control
on
and keep on
first.
first.
Yes, sir. Yes, sir. The others won't get this take control option, right?
Uh, yes, webinar only we can, all the speaker can actually do, or otherwise
Or
you can
otherwise you
share.
can share.
Uh,
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 I think some
I think
hauling
some
is
hauling
coming.
is coming.
Yes, sir.
I
I
see.
see.
Can you just
Can you just
mute your
mute
mic?
your mic?
Yeah. Yes. So now it is not. When your mic is open, then it is coming twice. Can you try speaking? I am muting and then you can try.
Yes, sir. Sir, is it better now, sir?
Even if
What is
what is
happening when
happening
your
when
mic
your
is
mic is
open,
open,
then it's
then
coming
it's coming
twice.
twice.
Twice?
Have you
Have you
connected
connected
twice?
twice?
No, sir.
Anyway, then when I speak, keep your mic mute, then it is coming well. Okay. Okay, so please keep control with you. You can do that. Okay, thank you.
Sir, is my voice clear, sir? Ashok, sir.
Yes, Vinay,
Yes,
your
Vinay,
voice
your
is
voice
very
is
clear.
very clear.
Okay, sir.
आपने YouTube तो नहीं खोला है क्योंकि आवाज गूंज रही है जब मैं बोल रहा हूँ। आपकी अगर
आपकी
माइक
अगर माइक ओपन है
और मैं
और मैं बोल रहा हूँ तो
आवाज
आवाज गूंज रही।
अभी सेकंड स्लाइड आ गया। लेट अस कीप ऑन फर्स्ट। या थैंक यू। गुड मॉर्निंग सर।
Good morning, sir.
गुड मॉर्निंग। आ रही वीडियो?
हाँ सर, आपकी वीडियो ऑडियो दोनों ठीक है सर।
आपसे बात कर लिया था अभी थोड़ी देर पहले।
ओके सर। लैंडलाइन उनका बिजी, मैं भी ट्राई किया सर, लैंडलाइन पे बिजी आ रहा था तो आपने बात कर लिया, ठीक है सर।
हाँ, तो बोले मुझे याद है तो
ओके सर।
ज्वाइन कर लूंगा उसको।
सर हम लोग का रजिस्ट्रेशन काफी आया है, 470 करीब आ गया था। तो जनरली वी सी की रजिस्ट्रेशन से ज्यादा लोग ज्वाइन करते हैं, तो टुडे वी एक्सपेक्ट मोर पार्टिसिपेंट्स सर।
होपफुली दे शुड ज्वाइन। टॉपिक अच्छी ली है।
Yes.
एंटीप्रेट के भी सभी लोग ज्वाइन करें, है ना?
Yes.
कुछ एलएसए का कल जब मैंने आपको मैसेज किया था ना,
Yes,
तो
sir.
कुछ एलएसए का कंफ्यूजन हुआ था, तो बोले यार आप कर रहे हो वेबिनार, मुझे पता नहीं लगा। मुझे लगा अरे कैसे नहीं पहुंचा एलएसए को। तो
सर
मेल
हमने सारी उनके जो डेजिग्नेशन मेल आईडी है जो अवेलेबल है सर, उन सब पे भेजा है सर। और 2 बार भेजा हम लोगों ने, 3 बार भेजा रहा था।
एक्चुअली क्या होता है ना, मोबाइल ने वो फिर मेमोरी ऐसे ही शॉर्ट कर दी है। तो हमें ना व्हाट्सएप या ऐसे करके बार बार भेजना ही पड़ता है ताकि याद रहे। फिर भी आपका आज जैसे व्हाट्सएप आया था तो भी मैंने फिर से भेज दिया ईमेल पर मेरे को। वो बोला था।
Yes.
Let's see, they should. Okay,
Yes.
I'll join back.
Yes.
और वो भी स्पीकर्स आर कमिंग,
Yes.
या वो फिर उस समय ज्वाइन करेंगे? उनको एक बार टेस्ट तो कर लिया ना?
हाँ सर, पहले टेस्ट कर लिया है सर। तो
क्वालकॉम वाले कहाँ से ज्वाइन करेंगे?
सभी
बेंगलोर।
इंडिया से ही ज्वाइन कर रहे हैं सर, ऑल आर ज्वाइनिंग फ्रॉम इंडिया।
Sunil ji साहब has written on that message that it's okay, good, you are planning for it. तो फिर कैसे फाइल वाइल मूव करना है देख लेते हैं। आज उनसे रिप्लाई का भी ट्राई टू परस्यू, है ना? देन विल प्रोसेस इट, राइट? ओके, आई जॉइन।
सर
Sir, you are on mute.
Yes, Vinay.
So I thought you were speaking something.
I was
I
talking
was talking
to member S office.
office.
Okay, sir. Okay.
So they would just be joining. Member S have joined, sir. I just made him presenter. Good morning, sir. Sir, आपकी आवाज चेक कर लेते सर. If you can just speak once, sir.
Hello. Good morning, sir.
Morning, sir. Morning, sir. We can hear you, sir. Yes, sir.
ठीक है.
ठीक है, sir.
अब बताओ. Good morning, Professor Moti from Institute of Science. Welcome.
Good morning. Thank you.
Ashok, I think we can start with the permission of DG and member service permission.
नमस्कार सर, सुनील
Morning,
कुमार
sir.
मॉर्निंग. हाँ,
Shall we start, sir?
यस,
Sure, sir.
नमस्कार भाई.
Good morning, sir. So respected Dr. Mahesh Shukla, sir, Member Services, DOT. Respected Sri Raju Sinha, sir, DG NTI PRIT. Sri B. Sunil Kumar, sir, DDG Wireless Access. Senior officers, our esteemed speaker from academia and industry, dear participants and friends. So a warm welcome to this webinar on technologies in 5G Advanced. So now may I request Sri B. Sunil Kumar, sir, DDG Wireless Access, to say a few words about the webinar. So over to you, sir.
So thank you, Ashok. We all know that 5G is a very revolutionary communication technology. It has revolutionized the communication technology from being a technology to connect humans to a technology which can connect everything. It has achieved these capabilities based on 3 pillars. One is the high throughput capability. Second one is the very low latency capability. And third is the very high connection density, apart from other smaller features. So now in 5G Advanced, we look forward to enabling this 5G technology with wings to fly, with other technologies like ability to integrate satellite to spread the 5G to the last 5% of the globe, which is most difficult to connect, with device-to-device communication, which can enable vehicle to everything, autonomous vehicles, Internet of Vehicles, etc., and many other things, like time-sensitive networking, which can really proliferate Industry 4.0 applications. It can give reduced capability devices, which can really multiply the application and the reach of IoT, and many such things which will enable. So in order to introduce this 5G advanced technology, NTI PRIT has envisaged this webinar today, and it will be kicked off by none other than Professor Chandramurthy from Indian Institute of Science, and an institution which does not require any introduction in the world even. So I'm also proud to say that we will be having sessions from global communications leaders like Qualcomm and Nokia to follow. With a small introduction, I request my colleague Vinay to take it forward.
Yes, so I request Vinay, our ADG, to tell about agenda of the webinar. Vinay, if you can just mute. Yeah, so I request Vinay to.
So, Honorable Member Services, Digital Communications Commission, Honorable Director General NTI PRIT, faculty members of NTI PRIT, esteemed speakers, and all our dear participants. A very good morning to all and welcome to today's webinar. The program schedule for today's webinar is as follows. So we have today with us, as Sir said, 5 speakers with us. I'll be giving a brief introduction about the speakers. Now, so as sir has already mentioned that it is an evolving journey, and today to talk about the latest trends in 5G, we are privileged to have with us what I must say luminaries of this 5G evolution, speakers who are not just part of this but are leading the efforts of development and standardization in this journey. So first of all, I welcome Professor Chandra R. Murthy from IISc Bangalore. Sir, research interests are in the areas of sparse signal recovery, energy harvesting based communication, performance analysis, and optimization of 5G and beyond communications. He has more than 85 journal papers and more than 110 conference papers to his credit. One of his papers was the recipient of Best Paper Award in Communications track at NCC 2014, and papers co-authored with his students received Student Best Paper Awards at IEEE. Also, he is a senior member of IEEE and serves on the editorial board of IEEE Transactions on Signal Processing and IEEE Transactions on Information Theory. Next, we will have Dr. Vinosh Babu James, is Technical Standards Director Associate from Qualcomm India. Welcome, sir. He will be talking about 3GPP 5G advanced standardization. He leads the Qualcomm standardization activities in India, and he engages in India as well as regional stakeholders on matters related to radio standardization, harmonization, and regulation. He has served as chairman of 5G working group in TSDSI and recently as the chairman of Future Communication Technologies in the TEC. He is also the convener of the 5G India Forum and a member of TIG 6G created by the DOT. He currently coordinates the IMT 2030 related activities for Qualcomm. He is also a senior member of IEEE. So welcome, sir. Next, we have with us Dr. Puneet Rathod from Qualcomm. He'll be taking a session on 3GPP work on broadcast. Dr. Puneet Rathod is a PhD from IIT Bombay and has more than 17 years of experience. He has a diverse experience of working as academic researcher, entrepreneur in public safety communication startups, and more recently in standardization research. He has contributed to national and international standardization efforts at TSDSI, 3GPP, IEEE, as well as ITUR. His recent work has been focused on spectrum regulation and standardization as a lead technical standards with Qualcomm Standards and Industry Organization. So welcome, sir. Next, we will have speakers from Nokia. So I welcome Ms. Smita Shetty from Nokia. She'll be delivering a session on 5G advanced technologies. And she is a senior device and modem standards researcher in Nokia Standards. She has extensive experience in the wireless telecommunications industry and has worked in the various roles in core as well as RAN domains. She is currently focused on research for radio standards development in 5G advanced technologies. So welcome, ma'am. And next we'll have Mr. Rajesh Banda from Nokia. He'll be taking a session on 5G advanced technologies. He is head of Department of Device Standards in Device Standards Research in Nokia. He focuses on radio standards development in 5G advanced technologies and promotes innovations in 6G. He has extensive experience in mobile communications and wireless technologies and has worked on network technologies, cellular protocol standardization, system engineering and design. He has worked on radio as well as core technologies with system analysis and go-to-market strategies, and has contributed to multiple patent filings and authored white papers in wireless communication technologies. With this, I'll just like to show the WA team of anti-IPRET. So we have DDG B. Sunil Kumar sir, and with us Director Sri Ashok Kumar sir and myself. With this brief introduction, now I would like to invite our respected Director General NTI-PRIT, Shri Raju Sinha sir, to deliver a welcome address for this session. Over to you, sir.
Thank you, Vinay. There was a call, sorry. Very good morning to all of you. We assembled this forenoon for the webinar on very relevant topic, technologies in 5G Advanced. First of all, I would like to welcome Member Services Digital Communication Commission, Dr. Mahesh Shukla sir, who has always been a source of inspiration to this institute for designing various programs and who has kindly acceded to our request to inaugurate the session and be part of the program. Thank you, sir. I also welcome senior officers and colleagues from DOT headquarters, LSAs, TEC, TRI, BSNL, MTNL, Enterprise, institutions working very ahead in this technology, academia, BSNL, MTNL, and many more. I also welcome learned speaker in the session, Professor Chandramurthy of IIC Bangalore, a signature person in this area. Dr. Vinod James and Dr. Puneet Rathore from Qualcomm. Madam Sumita Sethi and Mr. Rajesh Banda from Nokia. I also welcome officers of NTI, my colleague, working hard always in designing such program. Ladies and gentlemen, why we are here today? In general, it is observed now that the persons who are practicing telecom are now aware of the basics of 5G. Technologically, if we see the three ranges of bands, lower, mid, and millimeter band, open radio access network, distributed architecture of the core network, computation at the edge, slicing of the network, public and private 5G network. If we see feature-wise 5G, very high speed of more than 1 Gbps, low latency of less than 1 millisecond to support application to work on near real-time basis, high connection density, so on and so forth, which we are now normally aware of that. Why we are here? Because 5G has begun. IMC 2022 unveils a new digital universe. Honorable Prime Minister, while inaugurating IMC 2022, stated that 5G is the beginning of an infinite sky of opportunities. NT Priority, in its endeavor, under able guidance of member services, to make practitioners aware and keep updated about the happening in the sector, has organized this webinar, much talked topic now, technologies in 5G Advanced. I would like to thank my NT unit of wireless who has arranged this webinar. So friends, 5G evolution starting with release 18 is called 5G Advanced. 5G new radio and 5G core evolution is continuing in 3GPP towards 5G Advanced to ensure the success of 5G system and to expand the uses of 3GPP technology by supporting different use cases and verticals. 5G is enhanced by 5G Advanced, which is also the stepping stone to 6G. This will then make way to an era when the digital, physical, and human world will seamlessly fuse to trigger extrasensory experiences. Intelligent knowledge system will be combined with robust computation capabilities to make human industrially more efficient. We will be listening more from excellent spectrum of learned speakers, as you have seen just now in the session, on technologies being adopted in 5G Advanced, and will be deliberating on it. Once again, I welcome all of you to this webinar, and joining together on the this platform, we can clap for ourselves. Over to Vinay.
Thank you, sir. Now I invite Honorable Member Services, Dr. Mahesh Shukla, sir, to deliver an inaugural address for this webinar. Over to you, sir.
Good morning to all of you. Am I audible?
Yes, sir.
Yes, sir.
Well, good morning to all of you. First of all, I would like to welcome Professor Dr. Chandra Murthy from IISc Bangalore, who is representing the academia, and the team of Nokia, who are representing industry, and the Qualcomm, who are representing the innovators in the 5G space. And I think that is a perfect combination, perfect bouquet. And I also congratulate NTI-PRIT for having organized such a series of 5G related workshops. And it will go a long way in creating the proper ecosystem. This workshop is very timely. This webinar is very timely in the sense that various features are being worked out for the 5G advanced in the 3GPP. Release 17 and release 18 we are working on, and as it is mentioned in the speaking note that the rollout of 5G advanced, which is the release 18 of the 3GPP specification for the mobile technology, will be able to fully realize the ITU vision of the IMT 2020. Here I have something to say. I don't know whether they will stop at release 17. They will go further. Release 17, I don't know whether it is already in the market, already it came out or not for the prototypes. But in the Indian Mobile Congress, it was told that industry should be allowed to develop the prototypes, use them, while the release also can come later. It cannot be as in the past that the release will come first and then the prototype will be allowed and then there will be deployment. This line has caught my mind. And I also subscribe to this idea that while we are working on releases, the industry and the academia and the researchers, let them go ahead, let them work, let them prepare the prototypes, let them deploy, let the POCs be done, let the test beds be created, and all those things can continue while release also can be developed simultaneously depending upon the results of these prototypes. I think you all will agree. In fact, after the Indian Mobile Congress which recently happened from 1st October to 4th October, I am geared up and I am subscribing to this idea wholeheartedly. Because I'm told that this release is a precursor to 6G development. I'm also told that the major focus area in the 5G advanced will be the integration of the satellite communication and the non-terrestrial networks, NTNs. The use of artificial intelligence, machine learnings in various components, and the time-sensitive networking, which is important for the industry. Having said that, I'm yet to find any reasonable benefiting the public test use cases of the 5G. Operators have been showing that, sir, we will be using this in the ambulances, we will be using this in the mining industry, in the mining industry, we shall be using the driverless cars. But to my mind, I am yet to see large scale benefits of the 5G, large scale benefits of the test use cases. Nevertheless, I am sure that the market and the industry and the people, they will drive everything, and large scale benefits also will follow. Our job is to develop the technology, do the research, perfect it for commercialization, and to that effect, this webinar is going to be a huge success. And I also request NTI-PRIT that this is my concern that use cases, we are not finding many. Many use cases are not coming up. If we can have a webinar on 5G use cases only, We have seen some huge cases like ambulances and mining and road safety and all. But still, I feel that lot of work is to be done, lot of what you call brainstorming is to be done, and take a lot of interest in that. And as we discussed that day, we have to create the talent pool also, which can develop 5G technology. So development of the use cases and development of the skill pool for the 5G is one of the major area. And I also would like to request you that we could have requested our Secretary Telecom to inaugurate this session or inaugurate this webinar, because he is very technically savvy. He likes to learn technology. He likes to appreciate that you are doing such a wonderful work. He would have been very happy to receive our eminent speakers who are from the industry and from the IISc Bangalore. Yes, nothing is lost. We can have another session, or we can have one more session, or we can plan. But make it a point that we request Secretary Telecom and request through me also if needed, and 5 minutes of him should invariably be requested. We can postpone our timings also if you like. And then today also I will try. This will go on up to, I think, 1 p.m. I think it will go up to 1 p.m.
Yes, sir.
So let me
1:30,
see.
sir. 1:30.
So let me try if I can sneak, so if I can get some 5-10 minutes from him, because it's a very good workshop and he'll be very happy. So with these words I close. I'll not take much of your time. I think you all have noted what I request you, and with these words I close. Thank you very much. Thank you very much.
Thank you. Vinay, you are muted.
Thank you, sir. Thank you for your encouraging words as well as the inputs, sir. We have taken note of all these inputs and will surely do our best to implement these. So with this, before we begin our session, I just have a request to all the participants to kindly use the chat box to raise their queries so that we can take those queries either during the session by the speakers or at the end we can speak out these queries and our speakers can answer in the Q&A session towards the end. So now without further ado, I invite Professor Chandra R. Murthy to share with us his insights about the topic device-to-device communication. So welcome, sir, and over to you, sir.
Thank you very much for the very warm welcome. And it's with a little bit of trepidation that I begin this presentation. It's a little daunting to be the first speaker at a workshop like this. And also I must congratulate NTI-PRIT for such a huge audience. I did not expect that there would be 300 plus participants in this webinar. So congratulations on that. And so let's begin. This is a sort of very focused topic on device-to-device communications and how it is supported in 5G NR. To be frank, this is a topic that I have done quite a bit of research on in the LTE days, but I hadn't looked at it recently in terms of what kind of enhancements 5G NR is bringing to the idea of device-to-device communications. So this was a good opportunity for me to review what is going on from the standardization perspective. And I'm going to basically present to you some of things that I learned by looking through some recent documents from the standardization community. Okay, so just to give some background about device-to-device communication, it's also known as side-link or proximity services in LTE. It started quite early in Release 12 itself, and the main use case was in public safety networks like first responders. And in particular, three use cases, three scenarios were envisioned. In the first scenario, you have devices that can potentially talk to each other directly without going through the eNode B or the base station and the core network. And the idea is basically that if, let's say, UE1 wants to transfer a file or make a call to UE2, normally the way it would happen is that the UE1 would establish a connection with the base station, and then UE2 would also establish a connection with the base station, and the base station and the core network together, in fact, act as a relay to convey the data from UE1 to UE2. However, if UE1 and UE2 are proximal to each other, they're close by, then, and let's say both of them are actually quite far from the base station, then the power consumption involved in transmitting this signal from UE1 to UE2 can be much more than the power required if the transmission could happen in the direct mode. The second thing is, of course, what you can call spatial spectral reuse, namely that instead of using essentially two wireless channels, one here, one from the UE1 to the E node B, and another one from the E node B to UE2, you can make two with a single wireless channel between UE1 and UE2. And not only that, the E node B can potentially continue its communication with some other UE in its cell over the same time frequency resources. So it's a way to increase the spectral efficiency. It has lots of good things that are theoretically possible about it. But as we will see, realizing these benefits is actually quite challenging within the framework of a cellular communication system. The second scenario is partial coverage D2D scenario. This is the scenario where maybe UE2 is out of coverage and would like to get into the network or establish a connection with UE1. In that case, UE2, if it can discover UE1 to be sufficiently close to itself, it can establish a direct connection with UE1. And the third possibility is, let's say in some remote area, there is no network coverage, but rigging up the standards to allow these UEs to basically discover each other and establish connectivity with each other in the absence of a cellular network itself. So these are the three use cases that were envisioned for the side link in LTE. And then, so I will talk a little more about the advances or advancements to this D2D communications in later releases. But first of all, let's discuss a little bit about what are the use cases for enabling device-to-device communications. The first use case and the origin of the idea of D2D communication was for first responders. And the idea is to allow first responders in a disaster area, for example, to establish network or connectivity between each other, whether or not the cellular network signal or connectivity is available. And so a good example is this is FirstNet, whose mission is to deploy, operate, maintain, and improve improve high-speed broadband networks dedicated to public safety. And this needs to be reliable, highly secure, interoperable, etc. So this website, firstnet.com, is quite instructive in the use of D2D technology for establishing such networks. The second use is perhaps coverage extension. That is, it can extend the coverage of a cell by allowing D2D nodes to act as relays and thereby access the network even though they're out of coverage of the base station itself. The third use is capacity enhancement. This comes down to the spatial spectral reuse that I mentioned earlier. So by reusing the spectrum at different locations in space, you can enhance the overall bits per second per hertz per meter squared type of spectral efficiency. Another use is in what is called proximity services, which include commercial or advertisements. So for instance, if you're walking down a busy commercial area, as you pass by different stores, you can potentially get offers and advertisements from these commercial establishments. And then social networking, you can discover where if your friends are close by, you happen to be in somewhere outside, and then friends are close by, you can discover that they're close by, establish connections with them, and then meet up with them, etc. Disaster networks is related to public safety, but this is where the network itself has gone down, but you have a set of UEs that are still working. They can potentially connect with each other. And another very important use case that has caught attention in 5G NR is vehicular communication, or vehicle to X. X denotes anything. It could be vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure, etc. And these come with fairly high and stringent QoS, quality of service requirements, and can be enabled via D2D. So one prominent example here is vehicle platooning, where you have a set of vehicles that are driving together, and they could be driving across country, and where the network coverage may or may not exist. And in that case, they can try to establish connectivity with each other. And one other thing that is sort of my own thought on the use of D2D could be in improving the performance in rural networks, where the base station density could be quite low. And in that case, especially if a lot of the rural connectivity requirements are between people who are relatively close to each other, then it can significantly enhance the performance of rural networks by having the D2D communication facility. So in order to enable D2D, what needs to happen, right? So the first step would be device discovery. How does a UE know that there is the device that it's trying to connect to happens to be in close proximity with itself? One can think about a variety of ways of doing this. So for example, if the devices are equipped with GPS, then the devices can declare their GPS coordinates to the network, and then the network can compare the GPS coordinates of different devices and discover that certain devices are close to each other. However, physical proximity may not be sufficient, because if there are large buildings between these two devices that are close to each other, then their connectivity may not be possible, even though they are maybe physically not that far from each other. So ideally, this device discovery has to be based on signal measurements between the UEs. And so the standards have been written up to allow these devices to discover each other with various modes for device discovery. For example, one mode could be where a device sends out a signal which says, "I am here." And other devices that are able to receive that message that I am here can respond back to that device saying, I'm within the communication range of that device. The other way could be, are you there? Or is Aaron there? Something like that, where you query a specific UE and see if that is within your communication range. In that case, you can establish a direct connectivity. The second technical requirement is that of resource allocation, because after all, time frequency resources are a shared resource, and they're shared across all the entities in the network that are trying to communicate with each other. And so when you have device-to-device communication, the resource allocation has to be managed between the device-to-device connections as well as the ongoing cellular connections. So this is another crucial aspect, because the whole one of the primary reasons why cellular telephony works is because the resource allocation is tightly managed by the base station, and that is why so many devices can communicate very efficiently with each other without causing interference. And this resource allocation problem has to be revisited in the context of D2D. The third is mobility management, namely that these devices are not necessarily stationary. They could be mobile, and there are not only issues of managing the Doppler and frequency offsets between these devices, but also the fact that the connectivity may last an unpredictable amount of time. For example, if two vehicles are passing by each other, then the connectivity may only last a couple of seconds. The next issue is that of synchronization. Typically in cellular systems, the devices synchronize themselves to the base stations. But if you want to enable D2D, you need devices to be able to synchronize with each other. In particular, things like timing advance, which is something that devices use in order to ensure that their signals arrive at the base station at the right time, needed to be revisited and redesigned to enable D2D. So to say a few words to explain the idea of timing advance, this comes about because, in some sense, because of the slowness of the speed of light. So if the base station has its notion of timing, that is, it has its notion of slot boundaries, then the signals transmitted by the base station will be according to those slot boundaries. However, when the UEs receive the signal, it will be after some time, which depends on the time it takes for electromagnetic waves to propagate from the base station to the UE. Then when they respond, if they derive their timing based on the slot boundaries as observed at their location, then the signal will arrive with a delay which depends on twice the time delay between the base station and the UE, or rather the round trip time between the base station and the UE. So that means that the signals from different UEs arriving at the base station will all be offset by different amounts of time depending on their different distances from the base station. And so to counter that, what is done in cellular systems is that UEs don't transmit at the slot boundaries as they see from the base station's transmissions, but rather they do a timing advance and transmit it a little bit earlier so that after it propagates over the air and reaches the base station, it arrives at the base station at the slot boundaries. And this aspect works well in cellular systems with where you have a base station serving the users. But when you want to enable D2D communications, they need to figure out a way to ensure that their timings are between each other, timing and frequency are synchronized. And that's another major aspect that needed to be revisited in the context of D2D. The next aspect is the coexistence, because the D2D communications and the cellular communications are happening over the same time frequency resource. And also the potentially 5G NR and LTE can operate in the same frequency band and they will coexist. So in addition to 5G NR and LTE coexistence, one has to worry about the coexistence of side link with LTE and 5G NR. And when you go into unlicensed bands, operation in unlicensed bands, there could be many other devices that are also operating in the same time frequency resource grid. And all this existence needs to be managed by, for example, dynamic spectrum sharing between these different entities. Last but not least is security, privacy, and lawful interception. So once again, when you look at D2D communications, you want to make sure that the security and privacy are maintained and the hooks required for lawful interception of communications are still in place. So now a little bit of history on how D2D has evolved starting from release 12. In release 12, the main goal was to support proximity services, or ProSe, as it is called. So in order to do this, this is basically a mechanism to enable data exchange between UEs. And to do so, a new interface between the device and the between two devices was defined, and this is called the PC5 interface. And this interface bypasses the LTE base station or eNode B, and thereby improves the spectral efficiency. Also, relaying modes for coverage extension, as I showed you in the first slide, was enabled. There were two modes for resource allocation, mode 1 and mode 2. Mode 1 was a centralized scheduling mode, which is also called the in-coverage mode. This is when the UEs have, or at least one of the UEs has a connectivity with the eNode B. In that case, the eNode B can schedule the resources over which the two UEs can communicate over the PC5 interface. And the other is a distributed scheduling mode, or mode 2, which is in the out of coverage scenario, where the resources that devices need to use in order to communicate with each other can be either randomly chosen from a pool of available resources, or it could be pre-configured in the UE to pick one of those available resources to transmit. And to enable this resource allocation, two new channels were defined. The first is called the Physical Side Link Control Channel, PSCCH, which contains the side link control information. And this side link information is transmitted twice in time to enable it to be received correctly, to improve the detection probability. And there is also the physical side link shared channel, which is the data channel for side link. And this contains the transport block, and it is transmitted 4 times in time, basically to again improve its reliability. This multiple transmission is also sometimes called an open loop hybrid automatic repeat request, or open loop HARC transmission. Just 1 second here, I'm sorry. So this is called there is a small dialog box at the bottom, and I was just trying to see if I can get rid of it, but it seems not possible. Okay. And so the physical side link shared channel contains the transport block or the data block, and it's open loop hybrid ARQ, as I mentioned. So there's no opportunity for acknowledgements or feedback or even channel state measurement and reporting in these side link channels in release 12. In release 14, there were enhancements to support cellular vehicle to everything communications, and 2 additional modes were defined. Mode 3, which is again in coverage and scheduling done by the eNode B, but enhancements to accommodate high Doppler. For example, when 2 vehicles are moving opposite each other, you could have high Doppler frequency shifts, and also to accommodate higher vehicular density. And mode 4 is for out of coverage scenario with distributed scheduling. And the key difference is that here the resource allocation is based on sensing the spectrum, and there is a semi-persistent scheduling scheme which is used to reduce collisions when multiple devices wish to communicate with each other. And these channels, in these channels, the shared control channel as a side link control channel and the side link shared channel, that is PSCCH and PSSCH, are separated in frequency, not in time, as in the case of release 12. Then coming on to release 16, which is 5G New Radio. So basically, in release 16, the focus was completely on the V2X vehicle to everything else scenario, and the starting point was this steady enhancement 3GPP support for 5G V2X services with this 22.886 technical requirements document, which identified the design requirements for 25 different use cases of CV2X. The main advantages of 5G New Radio over LTE, as has already been mentioned, is the wide bandwidths or wider bandwidths than LTE, and multiple frequency bands, including the millimeter wave, and a flexible frame structure and numerology, and shorter transmit time intervals, and support for massive multiple antenna communications, and advanced modulation and coding schemes. So all of these are exploited to enhance the reliability, improve spectral efficiency, and reduce latency in CV2X, because you can imagine that if it's vehicle-to-vehicle communication, reliability and in particular reliability and latency are critical, because you want these messages to reach in real time. And the key specs for CV2X have peak data rates ranging from 25 megabits per second to 1 gigabit per second, latency of 5 milliseconds to 100 milliseconds, and reliability 90% to 99.99%. And of course, you cannot have all of these, all combinations within these, but depending on the quality of service requirements, you can choose the right combination of these specifications to achieve meet the QoS requirements. So this paper I found, which is available in open, it's openly available. It's an IEEE Access paper from 2021. It actually has an exhaustive list of various enhancements that were considered starting from release 12 of 3GPP all the way up to release 17. In release 17, in addition to V2X, these proximity services related enhancements were brought in, including device discovery, direct discovery, direct communications, UE relaying, and improvements to the power efficiency and reliability and lower latency. And what I liked about this table is it talks about each release and whether it's a work item or a study item and what the study item was about and which working groups considered each of these study items and what the objective of this, this item was, and finally what the corresponding technical requirements or technical specifications for this corresponding to this item was. So typically a study item will lead to a technical requirements document and a work item will lead to a technical specification. So so this is just an example of how resource provisioning is done for D2D or side link. Basically, you can see here that the several resource blocks, and you define what is called a side link bandwidth part, which basically is a set of subcarriers. And bandwidth parts are one other major enhancements in 5G compared to LTE, which makes it easier for devices to communicate with each other and the base station without having to scan the entire carrier bandwidth. And some of the slots are reserved because of ongoing cellular communications, and those cannot be used for side link. But essentially, you look at the time frequency resource grid and try to identify which resources and which time slots can be used for side link transmissions. So for example, in a slot where the synchronization block is transmitted, in such a block, you cannot transmit any side link information. Then several physical layer enhancements for side link, which is it basically inherits all the physical layer enhancements of 5G NR in general. And you can think of it as like a miniature version of the physical layer enhancements in 5G NR. It exploits the configurable numerologies, particularly the subcarrier spacing of 5G NR, and it allows for flexible allocation of time frequency resources. And LDPC coding is used for data, and polar coding is used for the control channels. And in 5G NR, one additional physical layer channel, which is called physical layer feedback channel for side link. So there's that's the S here, physical side link feedback channel, because this can be used to reduce the number of blind transmissions and improve the spectral efficiency. As I mentioned, in LTE, we use something called open loop HARQ. What that does is basically each transport block is transmitted exactly 4 times, and these transport blocks are combined at the receiver if required, and this is called soft combining, with the hope that the packet will go through or the transport block will go through. If the channel is in a good condition, you don't need 1 transmission and 3 retransmissions of every transport block, and so that way it's wasteful. But if the channel is bad, you may actually require more than 4 retransmissions of a block. So basically, this flexibility of configuring the number of retransmissions is something that 5G NR introduced. And again, the notion of bandwidth parts, which is part of 5G NR, was reused for side link communication also. which allows devices to communicate with each other without having to scan the whole carrier bandwidth for control signals. In turn, this improves the power efficiency of the device. And finally, multiple antenna beamforming support was added in 5G NR. So here is a graph illustrating the side link capacity and comparing it with LTE. And 5G NR allows for the number of HARQ retransmissions to range from 0 to, so here 1 means that only one transmission is done, that is there are no retransmissions, and 32 means that there is one initial transmission and 31 retransmissions. What can be seen from this picture is that although 5G NR allows for the number of HARQ retransmission to go beyond, say, 15 or so, beyond, if you use too many retransmissions, the capacity of 5G NR can even go below that of LTE. However, if you configure it with very low number of retransmissions, here only one retransmission, then you can actually achieve a capacity that is maybe about 20 times what you can achieve with LTE. And these improvements come from the fact that 5G NR allows for two-layer MIMO transmission, whereas LTE allowed only a single layer. So this gives you approximately 2 times capacity boost. And you can go up to 256 QAM modulation, that is this Qmax equal to 8 here. And you can configure the number of HARQ transmissions. So the next important aspect of Sidelink is how do you provide quality of service? And just quick check on time. How am I doing on time?
Sir, I think 45 minutes is over. So I don't know how many slides you may have, sir.
I have 2 more slides beyond this.
Please go ahead, sir. Please go ahead, sir.
Okay. So I think my time is up. So I'll just maybe briefly mention that QoS provisioning in D2D communications, especially when you're thinking of CV2X applications, is very important. And the way quality of service is provided in 5G NR is inherited for providing quality of service in Sidelink as well. Basically, in 5G NR, the application packets and the user plane function, which is residing in the 5G core, is mapped to various QoS flows. And in the G-Node B or the base station, these QoS flows are mapped to radio bearers, which then communicate these different QoS flows to the user equipment. The same framework is reused for the Sidelink. And just like there are 5G quality identifiers, PC5 quality identifiers, which is the PC5 is again the link between D2D devices. Several PC5 quality identifiers are defined in the standard, which allow for a variety of data rate and latency and packet error rate performances. Ongoing work in this area are enhancements to the device discovery, direct device discovery, direct communication, Sidelink relaying, and enhanced V2X services via Sidelink, and the interoperability between the base station to UE interface, which is called the UU interface, and the device to device interface, which is called the PC5 interface, and many more. So to summarize, basically in release 16, D2D focused on V2X, provided both on and off network support, flexible numerologies, and Sidelink specification in the physical layer. And new features are the provisioning of a feedback channel, enhanced coding modulation and coding schemes, and MIMO support, and new QoS metrics and corresponding resource management. And these improvements continued into release 17 to expand into non-V2X cases, in particular public safety, and enhancements to coexistence through dynamic spectrum sharing, and enhancements to discovery, relaying, and power efficiency, as well as the interoperability of the UU and PC5 interface. So we can expect D2D to continue to play an increasingly important role in future releases of the standards. One crucial reference I used to prepare this material is this NIST, National Institutes of Standards and Technology document, which is referenced here. With that, I conclude my talk. Thank you very much for your attention.
Thank you, sir. So now, sir, we can quickly take few questions. So we'll just take 2 to 3 questions. So first of all, Ashok sir has raised hand. So Ashok sir, please raise your query, sir.
Thank you, Vinay. And thank you, sir. Vinay, can you mute your mic?
Yes, sir.
Yeah, thank you. Sir, it was a wonderful presentation on D2D. So I have a very simple question that, as you said, that even without telecom service provider network, the devices would be able to talk to each other. You gave an example of platooning of the car and all. So just to confirm whether, for example, in an office, if everybody is having a device and D2D feature is enabled, so will we be able to create a network of devices and talk to each other, share our work and all, even without subscribing to this service from a TSP? If you can answer this.
Yes, yes. So in fact, in 5G NR, I didn't have the time to go into this. Different modes of communication have also been specified. For example, a broadcast mode where one UE can broadcast to several UEs in its vicinity. A group call mode, and in fact, there's something called Mission Critical Push to Talk, MCPTT feature, which allows for a group of devices to actually talk to each other, something like a walkie-talkie type network. So all of these features are part of the standards, yes.
Yeah, thank you. Over to Vinay for taking any other question in the chat box.
Yes, sir. Sir, DDG Sunil Kumar, sir, would you like to say something, sir?
Yeah, thank you, Vinay. It was a very wonderful talk by Professor. So I just want to confirm, sir, you have written in the summary slide that relaying will be is one of the subjects which are under study. So that will be enabling, like for PPDR network, disaster recovery networks. This is one of the feature which is available in the technologies like Tetra, where this relaying thing is very useful in extending the coverage. So such features, I mean, such things will be achievable going forward using this D2D?
Yes, indeed. So that's the idea. Exactly.
Okay, okay. Thanks a lot, sir.
Sir, we have few questions in the chat box, but as we have a lack of time, I'll just quickly club few questions.
Okay, if we are running late on time, what I can suggest is I can just answer in the chat itself. We can proceed further.
That will be
That will
fine.
be
Yes.
Okay. Just to make sure the workshop goes on time.
Yes, sir. Thanks a lot, sir, for
Thank
sharing.
you. Thank you very much for having me.
Thank you very much, sir.
Yes, sir. Sir, I would like to mention especially that Professor Murthy has been very keen to know about the audience profile in order to customize his presentation to suit their needs. And we all will agree that he has done a wonderful job for this, sir. Thanks a lot, sir. Now I invite our next speaker. Just a moment. So now I invite Dr. Vinod James, Technical Standards Director from Qualcomm. Sir, over to you, sir.
Vinod, your mic is mute.
Yeah, am I audible now?
Yes, Vinod.
Sure, thank you. Let me just quickly share my screen. Yeah, good afternoon. Thanks for having us today. Ashokji, can I get started?
Yes, yes, please go ahead.
Sure, thank you. So I think in the next 15 minutes or so, I will briefly introduce to the 3GPP 5G advanced evolution, where we are with respect to the 5G standards today and where we aspire to go, and probably also get a brief on how the 3GPP standards are actually evolving over a timeline. So this is the brief status today on the 5G deployments. We have about 200 operators with 5G, commercially deployed, and there are, additional operators lining up to roll out 5G, including, players from India who are catching up. For example, Vodafone Idea. There are about 1,250 plus 5G designs launched, 1 billion plus connections already served, and then 3.8 billion plus devices or smartphones estimated to be shipped between 2020 and 2024. And these 5G technology will be actually developed in 3GPP over a defined timeline, which is actually seen in this particular slide, where what we can see is, sometime around 2018, the release 15 design started. We prepared this unified platform based on which, a lot of services had to run over time, but they started base. So the mobile services is the one they initially targeted, and verticals and other applications started to get added to it over time. So today we have release 17 complete. Release 18 has started, which is the 5G advanced standard of things. So we just like to call it the second wave of 5G innovations, which will drive the ecosystem further. And then around 20 or 21 timeline, we will merge into the 6G standards from the same platform, right? So just to put in perspective, why do these standards evolve? Because there is a economic need which actually comes behind, and that is what motivates the ecosystem to invest in this particular technology. So this ever-expanding use of mobile into other industries other than connectivity is what is actually making it evolve, right? So things like mining, which is about $1 trillion estimated, or healthcare, which is above $1 trillion, or about new richer mobile experiences, which is pegged at 2.2 trillion in market value. This, along with smart manufacturing and retail and smart city, is what is driving these evolution going further, right? As I mentioned, release 17, it actually completes the first cycle of innovation where 5G was anticipated to serve or service mobile use cases. The same technology got used into allied fields or verticals, but the verticals actually brought in new use cases which need to be serviced. And if it is the same unified platform we are talking about, then that standard needs to evolve, right? So that's as much motivation I could actually give on why 3GPP is evolving and what is that particular target it is actually trying to bring into the economy. So it's evolving great. So in terms of technology or in terms of use cases and applications, what is it actually expected to bring in the release 18, which was not there in release 15, 16, or 17, right? So that's what this slide basically tries to explain about, right? So if you look in here, the first wave of enhanced mobile broadband or mobile broadband use cases, it actually evolved and then actually is adding more and more capability, more spectrum, further broadband enhancements, which will actually come in here. We'll start seeing early notions of full duplex MIMO being put into use. And then things like, extended reality, talk about, smart repeaters or extensions to the 5G NR cellular V2X system, which was there in release 16, getting evolved in release 18. All those enhancements will come along with use cases servicing non-terrestrial networks, AIML data-driven designs, broadcast-specific enhancements, and side-link-specific enhancements. Just to be cautious in here, this is just the 5G NR evolution. 4G LTE will continue to evolve based on missing use cases or services that will have to be provided. That's a continuous thing. Narrowband IoT, where we are seeing current traction, those will also continue to evolve. So release 18 will actually have a package which is mostly NR evolution, and then a little bit of other things which also need to come in. Adding further to it, what release 18 also ensures is a balanced evolution across key technology areas, right? So it is actually focusing on mobile broadband evolution and balancing the interest of the 5G verticals. It focuses on the immediate commercial needs and also tries to balance the long-term 5G vision. It is also about enhanced devices and the network evolution. So it's actually a complete package, a well thought about process, which will also then tell at some point what will be released 19 and beyond, and how it actually gets into the next technology standard that will actually come into practice. Okay. Taking it even further, the release 18 or the 5G advanced evolution package, which was approved like in the second quarter of 2022, it takes care largely about some of these key physical layer evolutions. It will have advanced downlink and uplink MIMO. There will be enhanced mobility. You will have in-band access and backhaul or smart repeaters coming as part of it. There will be duplexing. A large chunk of time is actually spent on AI/ML data-driven designs. And most importantly, the sustainability aspect, which is the green network, will become a study in the release 18 concept, right? So from a societal need, or for a country like India, where we have a huge services industry, or, where is this thought about, hey, 5G came in. Extended reality, which will eventually get into metaverse at some point in time, or talking to the opposite aspect to it, that how do you actually make it even lighter, getting into reduced capability devices, or how do you actually talk about more expanded siling? So the Professor Chandramurthy, he spoke about D2D aspects in his previous talk. 3GPP is actually going further into it and now talking about new use cases beyond the traditional cellular V2X or other aspects, right? Where 3GPP technology can be used. A lot of innovation is also going into supporting expanded positioning, new opportunities like drones, multicast, and other related enhancements. In my slide, I have also taken care to ensure that references are made to some of those 3GPP study items and work item proposals being linked to, so that when you have access to the slides, you should be able to get that document and refer to it. But largely, a few aspects that you will have to look for is there will be, of course, new use cases. There will be opportunities for data management related enhancements, AI/ML procedures, and network architecture enhancements, together targeting the expanded wireless machine learning and end-to-end RAN device and AR interface enhancements. There was some interest on AI/ML related aspects from NTT. Understand, document, and then try to figure out where exactly to go run in the AI/ML space. So a lot of the release 18 will focus on use cases. It will be talking about AI/ML models. It will also talk about the key ingredient, which is the evaluation methodology, including the moment you implement it, how do you actually assess those technologies? So together, it is actually going to build a future-ready system, which will be about early 5G adoptions in the 5G advanced space, and more keenly on the use of AI/ML for 6G and the future aspects. On the green network, the Release 18 project scope is to define base station energy consumption models, define evaluation methodology and the key performance indicators that will be needed, and study techniques on the base station and on the device side to improve network energy savings. So it's a new territory where the industry is actually venturing in because sustainability, as you know, is already a United Nations SDG goal. It's not just an aspiration; it's a target that need to be met. Even Sri Narendra Modi, our own Prime Minister, set target directly or indirectly on how we want to actually achieve it within the next 2 years, and with up to 2030. So if you want to go achieve all those things, we need to ensure that our needs are also made part of the study, which is part of the ongoing work happening in 3GPP. And I think I'm almost towards the end of my speech on this particular thing, where a 3GPP, the handset is no more a device. The device has actually expanded into a huge lot of other use cases, including drones, satellites, automotives, TV, your AR, VR headsets, your sensors, and a lot of these gadgets which actually make use of position, location, and other related enhancements. So from release 15 until now and then beyond, the enhancement are actually focusing on how to leverage ecosystem to be built around these services and use cases, which can then actually mean economic motivators for doing more, offering more services to the consumers. Quick last but one slide on how this evolution is actually getting into non-terrestrial networks, both from a broadband perspective and from IoT perspective. So both the 5G NR and the 5G IoT are getting into non-terrestrial networks mode. So 5G IoT, it's about tracking. It's about making use of small packets and then trying to actually get a larger reach. Whereas with respect to 5G NR, it's about how do you actually bring in these enhancements so that you are able to now offer terrestrial services through a satellite platform. So the references which I have given in my slides at the bottom, it actually points you to some of those studies which 3GPP will do in those dimensions. In summary, here are like few enhancements you will see in the Release 18 framework on these topics we just discussed, which is on AI/ML, full duplex, network power savings, XR, RedCap, enhanced non-terrestrial networks, sidelink on V2X, and the EMBB enhancements. I have listed down a few aspects which will be covered in Release 18. They may spill over, given how 3GPP schedules can actually account into it. But then I have also given pointers on what you should be expecting in Release 19 and the timing which actually comes beyond that. Along with the schedule, you should be looking for standardization in 3GPP. So with that, I think I should be almost at my time, and then thanking for the opportunity and see if we have some questions which I need to take.
Thank you, sir. So I think we see some raised hands. So first of all, let me invite Ashok Kumar. Okay, Ashok Kumar, sir. Please raise your query, sir.
Yeah, thank you, Vinay. Vinay, can you just mute your mic? I don't know. Thank you. So it was wonderful presentation, Vinod ji, as always. This question which I want to ask was asked by some earlier during earlier presentation, and I think you will be the best person to answer. The question was whether any product or the device is available based on D2D specification from either LTE era or 5G era. That was the question. So whether Qualcomm has done some platform or chipset around that, or some work is going on, if you are able to tell us.
Okay, I will try to answer it in two phases. So are there D2D solutions available? The answer is yes. So the automotive CV2X solution, which is already commercial, is actually a D2D solution. So the V2V mode, the vehicle-to-vehicle mode, it's actually a device-to-device service. The second aspect to that is there a developer platform which actually supports this particular aspect? I think that is also an S. What I should be probably doing is maybe after the end of this session, I can relay back to you on some of those Qualcomm enabled platform where developers can implement D2D solution, which you can then share it to the others.
Yeah, that's great. Now over to Vinay for taking up any other question, or maybe we can request Vinod ji also to answer the chat.
I will do that. That will be better. Thank you.
So thanks a lot, sir. Thanks for sharing your valuable experience in this ongoing work towards 5G advanced and even further after that, sir. So thanks a lot, sir. Now I invite our next speaker, and for those who have joined late, I will give a very brief introduction. And so I invite Dr. Puneet Rathod from Qualcomm, and I have already given an introduction, but should briefly say that he is contributing to national and international standardization efforts at TSDSI, 3GPP, IEEE, and as well as ITUR. So welcome, Dr. Puneet Rathod, and over to you.
Okay, I'll start sharing my screen. And if you could just confirm if it is visible. Is my screen visible? The presentation view?
Yes.
Okay. Thank you so much. First of all, let me start with thanking NTIPRIT for giving us this opportunity and making this presentation on the topic of 5G broadcast. It would be a pleasure to at least share the developments which have happened within the 3GPP standardization on this exciting topic of media consumption and audiovisual mode of content, which is also something which has become the most prominent of use cases, which is video kind of media. To begin with, let me just share, say, a few select use cases which drive such a standardization effort within 3GPP. When we talk about broadcast as a service, the first thing that comes to our mind is linear television, like pre-programmed television with a fixed schedule, it's like our television broadcast. So that is the most natural and prominent use case, which is linear video. And then the other part is interactive media. So it could be a possibility that there is either a sports or education content, and then combining with that linear video, there is interactivity, so that there can be question answers, there can be say chat along with viewing of sports and so on. Then there could be emergency messages, which can be national priority situations, alerts, or sending information to the public at large. And then finally, general file download. So what this could mean is, since we are talking in the context of broadcast, this general file download may be, say, software upgrades, firmware upgrades, very popular content which is common for a very large section of the user base. So all of these, the common theme among all of this is what could be common content which will be utilized by a very large fraction of the user base. And another common theme in all of this is, because it is coming from the 3GPP community or 3GPP standardization, the receiver could be a smartphone, or how to receive all of this content on a smartphone or a device which has, say, a 4G or a 5G modem. So that is the common theme and kind of use cases where this would, in general, belong. So 5G broadcast as a concept, as a technology, started within 3GPP way before. I mean, as a more elementary thing where the cellular operators within their own license spectrum could utilize a technology called EMBMS, which is Enhanced Multicast and Broadcast Services. And then those cellular operators could deliver, say, a multicast content to a group of users. And how they could share this information is by utilizing their own license spectrum resources and carve out certain amount of resources from their license spectrum bank. As 3GPP started looking at addressing the needs of multiple different verticals, and I think in both the previous speakers' discussions, both by Professor Chandramurthy and by Dr. Vinosh, there have been discussions about 3GPP trying to address more than just the traditional smartphone kind of user. It could be automotive, it could be satellite, it could be public safety, and many different new verticals. So broadcast, or a traditional broadcast, is one of those new verticals which is also getting attracted to utilizing 3GPP technology to deliver broadcast content. And 3GPP started deliberating on what could be the requirements that can be addressed for 5G broadcast. And few of those requirements which are listed on this slide are delivering or streaming content and to broadcast, example V2X, dynamically adjusting the broadcast area, like a large area or a smaller area depending on the user requirements. Also to be able to utilize both unicast and broadcast together as a converged network to the users, multiplexing between unicast and broadcast for different transmissions, using like a single channel 100% dedicated only for broadcast, planning or sharing the broadcast network across multiple operators, covering very large areas. Typically what we may imagine, say if we imagine a Doordarshan tower, so covering a very large area up to 100-kilometer cell radius, that kind of requirement, delivering to vehicles which are traveling at high speeds, and all this while leveraging all the technical enhancements that have happened within 3GPP, for example, MIMO, OFDM coding, and so on. So all of these requirements were defined within 3GPP starting release 14. And when we come to the 3GPP standardization process, 3GPP release 16, which was fully standardized a few years ago, is now fully supporting all of these requirements. So the standards are complete. This is something now, from a standard point of view, it can deliver broadcast in the broadcast band, for example, the UHF band, to deliver television broadcast. It can support, say, a very high power, high tower kind of configuration. So 100-kilometer kind of radius. It can be tailored to meet the broadcaster need, which would mean that if the mobile phone does not have a SIM card or does not even have an active 4G or a 5G connection, the device can be on a receive only mode or a downlink only mode, and it can utilize the dedicated broadcast spectrum to receive this free to air content. To make life easier for the broadcasters, there is also at the core network, there is integration at the service layer so that the broadcasters can utilize their existing encoding schemes, content format, DVB, DVB-I, Dash, HLS, CMAF, a lot of content encoding formats, packaging formats can be deployed on top of this 5G broadcast so that they don't have to re-encode or change any of their existing value chain. And finally, as with every other 3GPP feature, this continues to be enhanced in future releases. And one of those things is if we look at what we just saw in the previous slide, which is all the different features of 5G broadcast in release 16. All of this as a standardization happened because primarily broadcasters wanted this kind of a feature to happen. For example, BBC, European Broadcast Union, and the likes. And then the 3GPP community then tried to look at how can it apply its own technology to the broadcasters. When it comes to release 17, 3GPP further started enhancing and looking at new feature additions. One of them being utilizing the broadcasting channelization plan, channel bandwidths of 6 megahertz, 7 megahertz, 8 megahertz, and so on. Depending on the country, these different channel bandwidths could be supported. Then more architecture enhancements on the broadcast as well. So this is how the technology evolution took place within 3GPP. Going into a little more detail on individually how do these enhancements operate. From the architecture enhancement side, receive-only mode was something which was a very prominent feature which was added. It enables the devices to receive this broadcast without a SIM card, without even a 3GPP subscription. There's something which is truly of great value to a traditional broadcaster, because then they don't need to tie up with any of the telco operator to realize the benefit of such a broadcast solution. This is also something which can then be utilized for a shared broadcast. So if operators, more than one operator, and there is a popular content like IPL, and a lot of users watch this popular content on their smartphones. If the popular content is to be watched on more than one operator network, then every single operator network resources are individually getting occupied or consumed. But there can be this shared broadcast mechanism where this broadcast bearer can be common across multiple operators. And then it is a B2B agreement between the operators and this broadcaster, but then this common broadcast network can be shared across operators to deliver this unified kind of content. There is also a transport only mode. One of the things which I was mentioning about the architecture enhancements enabling a seamless pass through of broadcasters' own content in their own native format. And to enable this, there is a standardized interface between the content provider and the 3GPP core network. Coming to the radio level enhancements, there had to be some modifications or updates done to the physical layer to update multiple numerologies, update the cyclic prefixes so that very large cell sizes could be supported, and also high speed could be supported. This is also on the radio layer, a dedicated self-contained standalone broadcast can be supported. So that means that there is no other unicast kind of overhead in the network which is required. So if a broadcaster deploys the network, then 100% of the MBMS resources can be occupied in the radio bearer from a transmission point of view. From a device support, it could be different kind of UE categories from handhelds, car mounted antenna, and so on. And And then from the shared network point of view, a new MBFSN subframe, which is without the unicast control region. So truly supporting a standalone kind of a deployment. And this is going a little bit more deeper into how the entire end-to-end architecture may look like. If we talk about the 5G broadcast, on the top is what we see is the application layer. So and here on the left is the device side, and all of this on the right hand side is the network side. So on the device side, there could be a software application, which is a TV radio service application. And the broadcast content provider could be having their own content in their own format. This XMB interface is a standardized interface which will enable the broadcaster to connect to the 3GPP core network, the 5G core. This 5G core then can deliver all of this broadcast content using, say, a radio tower. This radio tower could be low power tower or a high power tower covering, say, an entire city at a time, delivering the content to the user equipment. Now, this application, so from the broadcaster point of view, all they have to care about is this application delivering the content to the 5G core network, and then all the radio enhancements, the entire standardization here is part of the 5G broadcast specification. Along with the 3GPP specification, this entire thing is also a technical report, which is defining the entire profile of how such a radio network looks like and how it can be deployed. So I was the rapporteur of this report, which was published inside TSDSI, also discussing the same enhancements. From a visualization of how a dedicated standalone or how a hybrid broadcast plus unicast network may look like. So on the top, this is a 5G broadcast receiver in a broadcast only mode. So the broadcast transmitter transmits from 5G broadcast receive, and this can be a truly standalone network, no involvement of a 4G or a 5G network. In addition to this, it is also possible that the 5G broadcaster, this is delivering, say, a broadcast content to a very large area to a mobile phone, which is capable of doing unicast. And we can imagine this as, say, an education TV content, which is delivering, say, education content to the entire city. And then this 4G or 5G can be utilized to, say, ask questions, do a question and answer, take quizzes while the broadcast is active. So this could be both these kind of modes are possible when this with the 5G broadcast standards. And then not only for this out of band kind of messaging, but the 5G broadcast can also do the hybrid 5G broadcast operation, where while the broadcast is happening in the broadcast band as the standalone 5G broadcast, the unicast could be utilized to repair some of the media content which is delivered. So if there is a lost frame, or if some of the packets are lost, then the unicast could fetch those lost packets so that the media content is continues to remain high quality. And then again, to assist the same application, it could be the electric program guide or the service guide. What is the next television show on the channel? So it can be more tightly integrated, or it can be supporting parallel unicast kind of content at the same time. So all these different services are possible. So there are the specifications overall are spread across multiple documents within 3GPP, and they are referenced below. In addition to this, there is also this TSDSI technical report. There is a HC profile, which talks about the 5G broadcast. So there are multiple standards artifacts which are fully ready for reference. And I'll just spend a couple of minutes to quickly talk about what is happening in the ecosystem on this 5G broadcast. So across the world in multiple places, either this is in advanced stages of discussion or early trials or demonstrations for delivering this 5G broadcast. And one specific example could be, I would say, is something which was also demonstrated in the recent India Mobile Congress as a dedicated 5G UHF broadcast with SIM-free operation, and also emergency broadcast messages. Let me spend just one more minute on the specific part of the emergency broadcast messages in the next slide, so that it can be more clearer. So one of the parts which we can consider for a better understanding is that because this entire technology is coming from the 3GPP ecosystem, it is a very straightforward way to integrate this broadcast receive in a traditional smartphone or a traditional 5G or 4G modem, which is capable of doing 3GPP technology. So a lot of building blocks are used: the coding, tone mapping, searcher, etc. There is a lot of convergence between the technologies. There are standardized interfaces to deliver broadcast and unicast, so that the device side convergence can be faster. The broadcast service layer integration is quicker, and then the ecosystem is fully standardized. Coming to the emergency notifications in particular, 3GPP, when we talk about 3GPP technologies and 3GPP emergency services, even if a mobile phone, a typical mobile phone, is outside service area of our own registered operator, we can be in the coverage area of any operator, and we will still be able to receive an emergency broadcast message. Consider a scenario where there is a natural calamity, and we have seen this situation within our own country where there is flooding or a cyclone. The traditional cellular network gets affected because they are much more localized. But then the broadcast infra is much further away from the main city. It is a much larger coverage area. By virtue of utilizing the 3GPP technology, the 5G broadcast from a radio technology, it can deliver a text message of this kind, which can be received by every mobile phone on within the coverage range. So the local cellular network can be down. All the towers may be out of power, but a far away broadcast tower can deliver this kind of a message. It can have embedded hyperlinks to further give more detailed multimedia detailed message, more audio-visual kind of content. And this is something which is becoming like a very highly a use case of high importance to countries, for example, Germany, China, and this is something which is which could be considered as a resiliency layer in case of national needs. And I think with this, I would conclude my presentation for this session, and would be happy to take some questions and discuss. Thank you.
Thank you. Yeah. Thank you, Puneet ji, for a wonderful presentation on broadcasting aspects of 5G. So I have one question for you. There are many questions in the chat box. I would request, in case you have access, you can answer there. A quick question from my side, like this multicast broadcast standards were there for LTE, but we didn't see any commercial use of that. So what is the difference in 5G, and what is likely that it will become a commercial use case of this broadcast and multicast feature of 5G?
Sure. I touched upon this very shortly, so maybe I could not spend time on this kind of question during my presentation, but it is a very good question. The multicast broadcast EMBMS in particular was always part of the 3GPP standard since long. The reason or the method to utilize that technology was a traditional cellular operator carving out their precious resources in their license band to deliver this kind of a common content. Now, already the cellular networks are completely clogged by massive amounts of video on demand kind of use cases. And this is the multicast or broadcast. This is best when there is common kind of content where the end users can only have a simple control, either to watch the content or to not watch the content. If the end user have any more control, if the end user can pause, rewind, replay, watch a different video, this kind of additional control translates this entire use case into a unicast kind of content. The traditional operator network is more suited for this unicast kind of content. This 5G broadcast, whatever got standardized in release 16, now enables this traditional broadcast linear TV kind of content. And there are several of these examples like popular events, IPL, education content, emergency, where such a use case can make very efficient use of the broadcast spectrum.
Yeah, thank you, Puneet ji. As you said, that linear TV kind of capability would really make it useful, and usage will increase. So thank you so much. And now over to Vinay for further. And I request Puneet ji if you can answer the question in chat.
Sure.
So thanks a lot, Dr. Puneet Rathod. And also we have with us Jitendra ji from Qualcomm. So thank you, sir, for joining this session and even answering some of the queries in the chat box. And also Jitendra ji has been very forthcoming in arranging for us the learned speakers. So thank you, sir. So now moving ahead from here, next speaker we have Miss Smita Shetty from Nokia, and she'll be taking a session on 5G advanced technologies. And she's a senior device and modem standards researcher in Nokia standards. So over to you, ma'am. Welcome.
Okay, so this is Rajesh here. And,
yes.
We are from Nokia. Greetings to all of the participants, and thank you for this opportunity. It's a great learning exercise, and I think this is the building block for future work. And we are happy to be part of this and sharing the knowledge. So I have my colleague Smita who will take over the technical presentation, and I'm here to support on the questions and queries as well as anything that comes up as a discussion. Yeah, thank you. Over to you, Smita.
Thank you. Rajesh ji, can I request you that you introduce your team, although Vinay has introduced. So if you can just introduce all your team who would be presenting for audience here, and then Smita can start.
Yeah, so we are just two of us here in this presentation, and then I would just want to introduce the team that we have built up in India to support the local ecosystem with respect to standards and also on the research side. Be it 5G advanced and 6G innovations that are coming up, right? And this is a team that works on the RAN 4 and RAN 5 groups of 3GPP, representing Nokia in the 3GPP discussions. And we give concept solutions to standardize in these two groups, RAN 4 and RAN 5. Specifically from the device side, we also look at RAN 5, which is defining the UV conformance test specifications that are the inputs for the some of the certification bodies like GCF, CITA, and etc. So this is the competence of the team that we have in Nokia here. And we are happy to, as I said, to support the local ecosystem here, be it government or also even the startups and academia we are interested to collaborate and co-work with the stakeholders here. Yeah, over to you, Smita. Thank you.
Thank you, and thank you so much for giving. Sorry. Okay, am I audible?
Yes.
Okay. Yeah, so thank you so much for giving us this opportunity to present our reviews on what is going on in 3GPP. So today we will talk about two topics. The first one will be non-terrestrial networks, or NTN. So we'll have a brief background as well as some of the basics from a satellite perspective. Then we will probably look at the 3GPP Release 17 functionalities that have been that have been defined so far. And then a summary, after which we will look at time-sensitive communications, a brief background on this topic, then 3GPP Release 17, what is the work ongoing there, and as well as the outlook for 3GPP Release 18. And so we'll start off with NTN, or 3GPP, or non-terrestrial networks. So one of the primary motivations for having standardizing NTN today is that we are today at 5G, and we are talking about not only communications between human beings, we are also talking about connecting things out there. For example, Internet of Things. But if one actually looks at the whole picture, is everything connected today? I mean, yes, a lot of things are connected. We have this technology in place. But there are also so many parts of the world which are not really connected. For example, these large water bodies like the oceans, there could be remote islands or extremely remote places out there on the earth which are not connected. And these could be due to various reasons. Probably because of the topology of the place, it's not really possible to have infrastructure out there, or the population is very, very sparse, which is again not very feasible for an operator to have to have dedicated infrastructure. So it's to address these kind of use cases, or that 3GPP today is looking at non-terrestrial networks, which will actually act as a complement to the existing terrestrial networks that we have today. So before we actually look at what 3GPP is doing, it would be good to have a brief, let's say, overview of what are these satellites all about. So in terms of satellites, there are various categories. The GEO satellites, which are very high up there, around 35,000 kilometers and so. Then there is the MEO, or the medium orbit, and those are around 8,000 to 20,000 kilometers. After which we have the LEO satellites, and these can range from 600 kilometers to 15,000 kilometers up above. So if we talk about the GEO satellite that we have, so the one-way delay is around 135.3 milliseconds, and to somebody who's out, who's on the ground over here, if he looks up, if he happens to look up at a GEO satellite, the relative speed is 0 milliseconds. So you'll feel that it is actually stationary. But this is not really the case in terms of, sorry about that. This is not really the case in terms of a MEO or a LEO satellite. If we look at a LEO satellite, which is 600 kilometers away, the delay, one-way delay is 6.4 milliseconds, and the relative speed is 7.5 kilometers per second. So it's moving very fast. And this is one of the major challenges in terms of NTN, because unlike terrestrial networks, wherein you had in terrestrial networks, if you see the base station is stationary, it's not moving. It's only the user that is moving. But in NTN, you also have, the base station, if it is up there on the satellite, it's moving. And you also, so that is also, that is something that needs to be considered while actually defining the specifications. So, and then we have the HAPS, which is around 20 to 50 kilometers from the Earth. So these are the various categories of satellites, and we will be talking about the LEO satellites today, or the low Earth orbit satellites today. Moving on, why exactly is it that LEO is being targeted in terms of NTN and 3GPP? So the geo satellites or the traditional satellites that we've had are weigh kind of thousands of kgs, whereas the LEO satellites are relatively lighter, which means that building these satellites as well as launching these satellites up into space is quite cheaper as compared to, let's say, launching a geo satellite. So that is one of the reasons why we always hear, that we have these geo satellites. Okay, I see a message saying that my screen is not visible. Is that so for everybody or?
The presentation is visible.
Okay, fine. Okay, then I'll continue. So, so this was one of the reasons why you see that LEO satellites are of major interest today. So, and since we also talked about HAPS in one of the earlier slides, or as they're called, high altitude platform stations. So these are nothing but the solar powered drones or balloons which can actually operate at a typical altitude of around 20 to 60 kilometers. They have their own advantages given that they are not so far from the Earth's surface. The propagation delay is lower than what we see in other satellite categories, which translates into a lower path loss and as well as negligible Doppler shifts. However, they also have their challenges, such as this equipment is subject to strict weight, size, and power budgets. And the antenna, it's not possible to have these really large antenna arrays and high transmit power on these HAPs. The equipment also needs to operate in extremely cold temperatures. So this is one disadvantage. And the feeder link could be susceptible to large rain fades. But so these are some of the advantages as well as disadvantages of HAPS. And HAPS is also being studied in 3GPP. But for today's talk, we will only focus on the LEO satellites. Yeah. So in terms of coverage, if we compare the LEO satellites and the HAPS and the GEO satellites, the ones in the dark blue is actually the coverage provided by a GEO satellite. So the coverage provided by a GEO satellite is rather huge, and a typical beam footprint in diameter could kind of extend up to 3,500 kilometers. Whereas a LEO satellite will probably have 10 to 1,000 kilometers as a beam footprint. I mean, this is in diameters. And HAPS will have 5 to 200 kilometers. So the coverage provided by a LEO satellite is smaller as compared to a GEO satellite. So the number of satellites required will be more. So now, if we look into what is ongoing in 3GPP. 3GPP has envisioned, when 5G was actually envisioned, so there were multiple use cases, and that's what we've heard through the course of this webinar today, that there have been so many use cases that have been envisioned and which can be catered to by 5G. And NTN happens to be one of those. So this is a part of the 5G advanced technology, and it is also one of the main pillars for 6G, which will be coming in the years to come. So the 5G use cases in terms of NTN, as we saw earlier, that it's not that everything is can be covered by terrestrial networks. So NTN will be a supplement to the terrestrial networks, wherein it can extend coverage to places where it's not possible to have terrestrial coverage for various reasons. And it can also be used in terms of let's say a backup when there's some kind of a disaster and the terrestrial network is not available because of the some kind of a natural disaster which has taken place over there. It's in those cases that the NTN network can take over and provide coverage. It can also provide coverage and the targeted verticals could be, let's say, transport, public safety. It could also be agriculture, finance, and automotive. We are also looking at, 3GPP is also looking at providing connectivity to onboard vehicles in terms of planes, drones, ships, etc. So in terms of the work ongoing in 3GPP, it started off as a study item. So there's been a very phased approach to NTN and 3GPP. And NTN, within 3GPP, a network which uses a spaceborne or an airborne vehicle for transmission is known as NTN. So the study item for for NTN and 3GPP started off with release 15, wherein there was a study for the channel models, the various deployment scenarios, as well as the agenda was to identify the potential impacts on NR, since we saw that non-terrestrial networks have certain different characteristics as compared to terrestrial networks in terms of round-trip time delays and latencies, as well as the fact that the satellite itself is moving. So next in release 16, we then had another study item wherein there was a study on the features and adaptations to the NR protocol, such that it suits the NTN use case. And now, in release 17, there are work items for which also target EMTC and NB-IoT. Of course, in release 17, the transparent architecture has been, the focus, and we will see what this transparent architecture is in the coming slides. So in release 18, of course, there is again a work item ongoing. There's a work item ongoing which will further have enhancements for NTN, and more of that later. So since we saw the architecture options in the earlier slide, so there are two different architecture options which are considered in 3GPP, and they're called as the transparent or bent pipe payload and the regenerative payload. So in the transparent payload, we have the G0B on the Earth. The satellite is actually amplifying and forwarding the UU signals, which means and the UU is the interface. However, one of the disadvantages is that it is going to have longer latencies. Then there is a regenerative payload, wherein the G0B is on the satellite. This, of course, will give you shorter latencies, but this has currently not been standardized in release 17. So the regenerative payload can also have a CU-DU split, wherein the G0B CU is on the Earth and the G0B DU is on the satellite. So there is an F1 interface between the G0B DU and the G0B CU. So the F1 is over the SRI or the satellite radio interface. The G0B DU will be hosting the RLC MAC and PHY, and the CU will be hosting the RRC SDAP and the PDCP. Then the regenerative payload can also have G0Bs with inter-satellite links, and these are still being, let's say, standardized or under study in 3GPP. So in terms of deployment options, there are two deployment options that are available. One is the earth-moving cells, and the other one is the earth-fixed cells. With the earth-moving cells, the cells move with the satellites across the Earth. And given that the cell moves, it also means that there is going to be continuous handovers. So UV is always going to be in and out of a cell. And there's another option called the earth-fixed cells, wherein the satellite will steer the beam at a fixed place on the Earth. And this is possible. So as long as the minimum elevation angle is not reached, the same satellite will kind of provide coverage. So handovers over here are bursty in nature and will happen only when a new satellite needs to take over. So both these options are standardized in release 17. So to recap, in NTN, in release 17, we had the transparent architecture. And one of the main assumptions was that GNSS is supported in the UE, which means that India coverage is not possible. And it supports both earth-moving as well as earth-fixed satellites. And it supports handheld as well as VSAT UV types. So NB-IoT and EMTC also are supported over NTN, and this also is taking the transparent architecture into consideration. GNSS is assumed, but there is a limitation. It is not possible to use it simultaneously with the 3GPP radio. And there is still work ongoing in terms of discontinuous coverage considerations and the solutions which need to actually cater to this, and this is focusing primarily on a handheld UV. So we'll now look at some of the challenges. When we say there are challenges in delivering NR as is for NTN, so what are those challenges? I mean, taking a LEO, which is at 600 kilometers, as an example, given that, and as we saw earlier, that LEO is at a large distance. I mean, this distance is not something that one could actually see in a terrestrial network. So this large distance will actually mean that it is going to affect the link budget. It will also give, and it also has this, I mean, this large distance also translates into a large round trip time. So which means it can go up to 12.9 milliseconds for a regenerative, and it will be further increased for a transparent case. So the AMC or the modulation coding may be out of date. It also means that the CQI reporting, etc., will be out of date by the time it actually reaches. It will cause HARC issues because there could be a case that the number of HARC processes may expire even before the first feedback is received. Then the next issue is that it's not only, as we saw, I mean, it's not only with the user which is moving, the satellite also is moving, and the satellite is moving rather fast. So this means there is a very dynamic environment, which will cause mobility issues, wherein the UV will probably keep having handovers, either between satellites or within the satellites, between the satellite beams. And in turn, there's going to be the timing advance that we have in NR today cannot be used as is. Because, I mean, this is, let's say in case of RAR, there are only 12 bits, and the timing advance for uplink synchronization has up from 0 to 3,846 steps for timing correction to determine the UV's distance to the G node B. And the step size depends on the subcarrier spacing. So one of the main problems is that the minimum distance to a LEO satellite is 600 kilometers. And the other problem is that the cell size, as we saw, could be up to 500 kilometers. However, let's say if you take the existing procedures today, the maximum distance with 15 kilohertz subcarrier spacing can be up to 300 kilometers. So anything beyond this will fall out of the random access detection window, which means the G node will never hear anything from the UV. So these have to be taken. I mean, there are enhancements which have been done within the NR standardization to address this issue. In terms of architecture, also there has been, the intersatellite links have to be studied. So this is more in terms of regenerative architecture and country identification. Now, as we see that the beam footprint is, or the cell size is very large, I mean, in terms of NTN, and it could be a case that this cell could, I mean, provide coverage to two countries. It could be two neighboring countries. So this is something that is it could be of concern in terms of regulatory policies, because one country will have one regulatory policy, the other may have something else. It also could be cause for concern in terms of security. So there is an ongoing, work item within 3GPP in terms of country identification in Release 18. So we will look at some of the solutions, not all, which have been today defined. So in terms of mobility for earth-moving cells, we see that there are two types. And one is, first and foremost, with 50 kilometer cells, mobility happens around every 5 seconds, with an earth-moving cell, assuming the UV itself is stationary. So if you look at the picture over here, there are two types of mobility scenarios. One is the intra-satellite mobility, wherein the same feeder link and the UV will have the same feeder link, and it will have experience similar service link delays and more correlated measurement errors. Whereas in terms of inter-satellite mobility, it will have different feeder and service link delays, and the measurement errors will also be correlated. So one of the ways to counter this is to use the conventional handovers that we have is not really very useful because of in terms of NTN, because of the large delays, and given that the radio conditions are changing very fast. So to counter this, conditional handover is being used for NTN, but conditional handover is not used as is. It is, I mean, there are new conditions. For example, for the earth fixed cell, there is a timing window which is given. And for the earth moving cells, the radio conditions can be enhanced with the relative locations in the cell. So these are some of the enhancements that are there for mobility. In terms of the tracking area also, there are some enhancements in terms of soft switch, because as the UV, I mean, these cells will broadcast more than one tracking area code as they move, because we know the satellite moves, so the coverage moves with the satellite. So that is more in terms of an earth moving cell. And then country identification. Yes, this is a major concern today, because it is very important to identify the specific country where the UV is located for various reasons. And this could also be in terms of charging or probably regulatory requirements. And since we know that the cell size can be huge in terms of NTN, it is very, very important that the UV is actually, it is possible to pinpoint the UV location and to know that the UV is actually where it claims to be. It could be that the UV says that it is in location A, but it could actually be in location B, and this could be a security breach. So, I mean, and there is an ongoing, work item within 3GPP to identify where the exact UV location is, and to enable the network to deny access to the UV in case it is in a different location than where it claims to be. So going forward in release 18, there are further enhancements in terms of coverage enhancements, wherein voice over NTN on smartphones can be provided. We're also looking at network verified or network-based positioning without relying on GNSS, and seamless mobility between terrestrial networks and non-terrestrial networks is also being studied, so that the UV can move from a terrestrial network to a non-terrestrial network seamlessly wherever required and wherever the coverage is available. And in terms of IoT, there are further enhancements and also support for NTN on RedCap devices or reduced capability devices is also being studied. And HAPS solutions for HAPS are also supported in release 18. So to summarize what we have, what is being done in 3GPP today, 3GPP release 17 is finalized. I mean, there is still some topics which are under discussion. It is more or less finalized. For example, mobility issues are still being discussed in RAN 3. And in release 18, we saw some of the enhancements that will be done. There is also outlook for release 19, wherein the regenerative architecture and inter-satellite links will be studied. There is also a plan to look at the GEO and the LEO interworking, store and forward operations for IoT, and GNSS-free operations are also being looked at in release 19. So this, so NTN is an integral part of 6G, and it will evolve over the years in the various releases in 3GPP. Moving on, I think I am short on time, so I'll move on to time-sensitive communications. So time-sensitive communications is one topic, and within 3GPP, and this is actually 3GPP has three. We know that it has three use cases. One is the URLLC use cases, the eMBB use cases, and then there is the machine type, massive machine type MMTC use cases that we have today. And in terms of ultra reliable, low latency communications, which are actually targeting the industry 4.0 or automation, factory automation, robotics, or probably live tracking, advanced logistic use cases. It is here that TSC will be very useful. And this is a system, so TSC is basically nothing but an adaptation of the 5G system to support TSN, which is time-sensitive networking. And so there are a whole lot of new terms in this technology. So I have just given a brief overview of some of them over here. For example, time-sensitive networking. It is nothing but a set of standards which are used to define various mechanisms for enabling time-sensitive transmission of data over Ethernet. And this has been developed by the time-sensitive networking task group IEEE 8021. Then there is also the IETF deterministic networking, and you'll also hear, I mean, when you're actually going through literature, you will come across these terms quite frequently. So deterministic networking, or DetNet as it's called, is a set of standards which are defined to enable deterministic paths that operate over layer 2 bridges and layer 3 routed segments. And then there is the time-sensitive communications, which is nothing but an adaptation of the 5G system as a whole to support all of the above that we discussed. Yeah, wherein the and we're looking at extremely low latencies and high reliability kind of services. So the 3GPP roadmap for IIoT or industrial IoT, it actually started off in release 16, wherein it's called a vertical LAN. So this supported integration of the IEEE TSN centralized configuration model. Then it supports the GPTP or the generic PTP, synchronization, distribution of external clock via the 5GS. It supports the best master clock is configured over here. It also introduces a term called the traffic assistance characteristics, and this helps in optimized scheduling of deterministic traffic. In release 17, there have been further enablers for TSC and time synchronization for any application. So what we have over here is enablers or enhancements to support time-sensitive communication, and the ability to support application functions, activated time sync, P2P, uplink and UV2E time sync, and BMCA, which is the best master clock algorithms. Deterministic applications, which say an AF can also actually request certain QoS parameters. The TSC assistance characteristics. So these are the, let's say, toolboxes, as they call them, in release 17 industrial IoT. And there are further, the release 18 outlook actually is of further enhancements, whereby you can have resilient timing and TSC and URLC enhancements in terms of improvements in the ultra low latency, availability, and jitter characteristics. So if you look at this picture over here as a whole, so we have the 5G system over here, which acts as a logical TSN bridge. And this is adapted to the IEEE TSN. So there is the DSC-TT, which is the device-side TSN translator. And we have the network-side TSN translator. There is also the TSN-AF, which is the TSN application function. Then at the edge of the network, there is the CUC, which is the centralized network configuration. It can be used for network devices. And the centralized user configuration, which can be applied to the end stations or the use. So the CUC is responsible for inter-domain collaboration of network information and device configurations. The CNC would be more from a monitoring management perspective. So what we see is that, and as we saw that in release 17, there are certain features which are also called as tools that can be supported as a whole or independently. So I have given a few of them over here. For example, the AF influenced QoS and traffic pattern, the TSC AI provisioning. So the TSC AI is nothing but a set of parameters like the flow direction, which kind of tells you whether the direction of the TSC flow is in the uplink or the downlink, or the periodicity, which refers to the time period between the start of two bursts. Then the burst arrival time, which is the latest possible time when the first packet of the data burst arrives, or the survival time, which is defined as the time period an application can survive without any burst. And then there are also the time synchronization as a service, which is, so there can be two clocks which are running in parallel within the 5G system, but more of that later when we talk about time synchronization. And then there is also the exposure functionality, which supports the 5GS TSC for Ethernet and IPPDU sessions. So in terms of time synchronization, what is it? It is nothing but, and why is it required? So a synchronized system is very important because all the nodes in the system will then actually it will provide the same signal reference to all the nodes in the system. So this is very important for a coordinated network. And in terms of release 16 and 17, there have been certain enablers or features which have been introduced for accurate or absolute time synchronization for any application. One of them was the propagation delay compensation. So there are two, in fact, there are two methods which are supported in PDC. One is the legacy timing advanced, and the other one is the round trip time based on the receive and the transmit measurements. So the GNOD will select which PDC method is needed based on the UU error budget which it receives. So we'll then look at the release 18 outlook. So some of the key objectives for release 18 are support for 5G timing resiliency requirements, then to provide time synchronization service for a particular coverage area, to control the 5G time synchronization service based on subscription, also to support low latency and low jitter. So in terms of that, we're looking at interworking with TS and transport networks, RAN to provide feedback for application to determine its burst transmission schedules, and as well as to actually look at how to provide high reliability exposure and ability for an application function to influence the reliability that is provided by the 5G system as a whole. And with this, I come to the end of my presentation. I think I have overshot the time that was provided to us. So thank you. Thank you.
No problem. Thanks a lot, Ms. Smita. It was a wonderful presentation. So, Ashok Kumar sir, please open your mics.
Yeah, thank you, Vinay, and thank you, Smita ji, for wonderful presentation. And so basically, we are in right time. Our webinar is up to 1:30, so we still have time. So I have one question for you, Smita, that as far as standards of NTN integration with 5G is concerned, so I have seen a lot many TR being issued from 3GPP in various releases, started from release 15 and odds, and so on. So do we have any TS also on this particular NTN? My question is related to NTN, or these are the TRs only, or whether we require TS or not. So that's the question, if you want to answer, Smita.
A TR is nothing but a technical requirement, and once, I mean, since we see, as you've seen, that we have these work items which are there in release 17 and release 18. So once these are agreed upon, these will get translated into a technical specification or a TS, as you just mentioned. So some of them are already agreed upon in 3GPP, and we should have some of the specifications out. A few of them will probably come in the coming months. So yes, TSs will be there, but there won't be a dedicated TS per se for NTN. This will be part of the existing TSs, and then you'll have certain sections which are adapted for NTN within them.
So as of now, we don't have released TS where this NTN aspect is there, but TRs are of course there.
TRs are there, yes, but TS also should be there for some of them, But as I discussed, yes, mobility is also, I mean, mobility is still being discussed in RAN 3. So we won't really have specification out until and unless it's been agreed upon. So, but the specification, I mean, but to answer your question, it will be there, as soon as it's agreed upon. So whatever is being agreed should be there in the TS today. Yeah.
I think Sunil sir has opened the. Sir, over to you.
Yeah, thank you, ma'am, for a very good presentation again. I have one query regarding this satellite integration of 5G. So you mentioned that the country-specific boundaries will have to be sensed by the networks, and accordingly it has to be done. And in this regard, like many countries will have specific requirements regarding the communication facilities given to the borders, like India may permit prepaid only or only postpaid or maybe nothing in certain areas. So do you depend upon the location as reported by the mobile, or there are some other technologies?
You're right, and it's a very valid question, which is why, because this is actually a cause for concern. It could be that two countries will have separate regulatory requirements. Somebody may have separate, let's say, policy in terms of charging, as you just said, prepaid. And so it is important that today, one of the ideas actually which are being discussed is in terms of PLMN, wherein the network will provide access to the UE based on the PLMNs. But it is still a work which is ongoing because it could be a case that the UE says that I'm over here and it could be somewhere else, for various reasons, right? So different, let's say, different methods are being kind of discussed to actually identify the location of the UE. So that is still a work in progress, and yes, it is one of the major topics within Release 18, 3GPP Release 18.
Yeah, sure.
I think Raju Sinha sir had also opened the video and mic, sir, if you are around.
Yeah.
Sir, yes.
Thanks, madam, for your nice presentation. Has this been utilized in countries the way the communication through satellite for mobile communication? What you have shown just. That was one question. Second question coming to mind, how much power UE will require to communicate with LEO? Is it allowed considering human safety?
You're right. So in terms, to answer your first question, has it, and if I got the question correctly, it was that has it been used anywhere or has this been deployed anywhere in any country, right?
Yes.
So normally what we see is that from a release, there is always a time of around 1.5 to 2 years, wherein you actually see the features or functionalities being deployed in the networks. So it is that much of time from the standardization activity to the feature being available with the vendor, and these are mandatory requirements, and those will be actually the mandatory features, and then we come to use cases like NTN, etc. So as of now, no, because it's still work in progress, and this technology is very, very nascent today. There are a lot of things which need to be identified. I mean, like we had questions before about the UE location, etc. So it's only once those are, all these aspects are in place that we will really see commercial deployments for this technology. So what we have today is just, I mean, it's very nascent. It has just started today. Yeah, sorry. You also had a second question.
Yeah,
and
about
that was
the power of the
UE power. Yes. So today, the study has only been in terms of the S and the L bands, which are the low bands, and there we don't really see, I mean, an issue in terms of the UE power. But now study in Release 18 will start on the KU and the KA bands. So the KU band is from 12 to 18 gigahertz, and the KA is, as you know, from 26 gigahertz onwards.
Yes.
So probably we'll also have some specifications from a UE perspective, and those also will be studied.
Thank you.
Yeah, thank you, sir. And thank you, Rajesh ji, for answering the questions in the chat box. There are still few more questions are coming, and we also invite our participants. If you have any question, you can write in chat box, or you can raise the hand. Now it's a time for question answer. So even you can open your mic. Please raise your hand. To manage this, I request Vinay to go ahead.
So participants, you can raise your hand if you have any questions, or there are a few questions in the chat box also.
Maybe you can read the question.
I'll just read the latest question that is there. Is the question from Bala Bhaskar ji is that I want to know, does 5G overcome the low latency and packet loss problems with high energy bands? Any of the speaker would like to comment on this, or maybe I think Ashok sir can also comment on this. Yes,
you can repeat the question.
Does 5G overcome the low latency and packet loss problem
with high energy bands.
Okay. Maybe Vinayji can go on mute. It's kind of echoing. Yeah. So 5G as a technology, right? We all know that it is quite different compared to the 4G in terms of the dimension that it addresses. 4G has been a single dimension technology which mainly caters to the mobile broadband, right? So that's a predominant use case there. And 5G has brought in additional 2 dimensions. So I usually refer to that as 3-dimension technology, which brings in these 2 critical dimensions that enables quite a plenty of use cases, in the industries and verticals and enterprises. So one of the dimensions is the ultra low latency, right? So 5G as such is going to address the latency aspects, bringing them down to sub millisecond level, right? So that's the target. And it is not in one specification that it happens. So it is going to be an evolutionary step. So we are going to work on this up to even in 6G also, that there is a requirement on these low latencies to bring it down to nanosecond, microseconds and things like that. So from that perspective, 5G is addressing the low latencies. And I'm not sure if we are now referring to high bands or high energy bands. You mean the satellite bands or maybe beyond 6 gigahertz or FR2 bands, but overall, I think latency aspect is being covered for all the bands that are envisioned today in terms of 5G advanced and also for the 5G, of course. So low latency is the critical requirement that is being evolving in the specifications that are coming up in the future as well, up to release 20.
There was some raised hand. I think I have opened for Balaji Prasad. Balaji, if you like to ask your question. I have also opened mic for Mr. Paul. You can open your mic and please ask your question. Mr. Paul. Mr. Balaji and Mr. Paul can open your mic and ask your question. Or if you are unable to, please write in chat box. Yeah.
Yeah, so I missed to address the second part of the question. They also asked about packet loss problems. I think this is about reliability. So it's also covered in the same dimension of ultra low latency and reliability, right? So this is in various features, we are addressing this reliability topic as well in the 5G specifications itself, and in 5G advanced, we go even more stringent on the reliability requirements. From the technology perspective, there are spectrum efficiencies and spectral spatial diversity. All of these topics, they cover the reliability aspects. Yeah. Sorry, any new questions?
Maybe Mr. Paul, if you can open your mic and ask your question. I think they are not able to open. They have written in the chat box. I
have opened my mic. My question to the first speaker, he was talking about dynamic spectrum sharing. Is dynamic spectrum sharing is related to cognitive radio concept? The professor from IISc Bangalore, he was giving in a speech about dynamic spectrum sharing will be used. So can he expedite whether a cognitive radio will be the technology used for dynamic spectrum sharing? Because as on date, DOT has not given license or given the freedom of using cognitive radio among the operators. That's my question.
Okay, I think Professor has left. So may I try to answer?
Yeah, certainly. So, yeah. Because so he has made a remark of dynamic spectrum sharing shall be used. So will cognitive radio will be the technology used for dynamic spectrum sharing?
Okay, so as far as 3GPP standards, which are already released in release 15 and 16 about dynamic spectrum sharing. So that is about, suppose you have a certain spectrum on which you are running 4G. So the same spectrum can also be used for 5G in a dynamic way. That means, for example, every 1 millisecond, you will decide that how much of the spectrum would be used by 4G and how much spectrum would be used by 5G. That means the base station of 4G and 5G would be coordinating with each other and every millisecond dynamically it will be decided. So initially, suppose you have less customer of 5G, so less bandwidth would be given for 5G and higher for the 4G. And if the 5G customer increases, so they will utilize more spectrum. So that is dynamic spectrum sharing as far as 3GPP standards are concerned. It is not related to cognitive radio as such, what Professor told. I hope I answered your question.
Yeah, thank you. Thank you very much. Thanks.
Thank
you very much, sir.
Thank you. There are more raised hand. If you can just open their mics. Yeah, Balaji, do you really want to ask question or? Okay. Dr. B.S. Murthy have raised hand. So please go ahead, Murthy ji. I am just allowing your mic. Mr. Murthy, you can ask your question.
Yeah. Am I audible, please?
Yes.
Yes, sir. Sir, Ashok Kumar, sir, I would like to just start to what you said about dynamic spectrum sharing. Actually, dynamic spectrum sharing in cognitive radio is like if a spectrum is of a licensee is being left unutilized, like certain channels may not be used, entire spectrum may not be used by the service provider at all times. During that period, when the spectrum, that such spaces are called white spaces, those things can be used by another licensee. That means that is not allowed by Department of Telecom, I think, as of now, because that is between two TSPs. That is the let us say Jio is having some spectrum, and in that spectrum, if some channels are vacant, though they can be used by some other TSP, so that is not allowed. That's what my knowledge. I just wanted to add to that. Thank you, sir.
Yeah, so basically the spectrum sharing aspect, like there are certain law in place by DOT. So there are ways operator can share spectrum with each other. So they have to follow those rules. So they cannot go beyond. But as far as dynamic spectrum sharing, which is there in the standard, is concerned, so if a same operator is utilizing the same spectrum for 4G, 5G, or for any technology, there is no restriction. So as such, DSS, as per the standard available today, is a legal one and anybody can use. And if you want to just study a kind of a use case in USA, one of the operator, Verizon, have extensively used dynamic spectrum sharing. In fact, they have enabled entire 4G infrastructure, which covers entire country with 5G using the DSS technology.
Yeah, excellent, sir. Thank you.
Thank you. So Ken Rai sir, I have opened your mic. Please open your mic and ask your question. And this may be the last question because it's already 1:30. Ken Rai Sahab, do you want to ask any question? Please open your mic. We have enabled. I think he's not able to. So since sir has opened the mic, maybe we can hear from sir before we do a vote of thanks and close.
I was telling Ken Rai Sahab is a regular attendee. He was advisor earlier in the department. So can you request again him?
So we have enabled. So he is not able to open the mic, maybe because of some issue at his end. As such, I have enabled him. Yeah, maybe you can take his question in the chat box.
Correct.
So, sir, if you have permission, then I can request Vinay for vote of thanks, or if Sunil sir want to say something at the end.
No, it's okay. Vinay can go ahead.
Yeah. No, thanks, Ashok. I think it has been a good session from all the esteemed speakers. So Vinay can go ahead. Honor them with an vote of thanks.
So thank you, sir. Sir, so we had nearly more than 400 participants at any time, and we had nearly, I think, around 1,000 participants who had joined the session at some moment of the time. So, sir, seeing this hoping response, I felt very relieved that we had this event in online mode. Otherwise, we would have to shift to or search for bigger rooms in between. So Sir, I would like to thank Member Services for gracing the occasion and for his encouraging words. And he has guided us and given many inputs. We would definitely work on those inputs. And I also thank DG NTI-PRIT for guiding us to organize such events regularly. I thank all the speakers and the respective teams, Professor Murthy, Puneet ji, Vinod ji, Jitendra ji, Ms. Smita and Rajesh ji, for sparing their valuable time and sharing their experience and insights on this emerging aspect of 5G Advanced. And we have already received multiple emails, messages to convey that participants have benefited from the webinar. And we have also shared a feedback form to get more feedback from them. So I would like to thank all the participants. Their participation and kind words encourages us to continue such initiatives. Thanks a lot, and we pass on all their appreciations to our learned speakers. So thanks again to the speakers. And I would like to especially thank DDGWA Shri B. Sunil Kumar sir for his meticulous planning and designing of such topics and ensuring that we have the best speakers from the industry always. And I also thank Ashok sir, Director WA, for always pushing forward our own frontiers and to do better than the best. So thank you, sir. With that, sir, we can close our webinar for today, sir. Thank you all. Have a nice day.
Thank you. Thank you.
Thank you, sir.